Good morning, everyone. We have always took the advantage of wind energy from the beginning, in sailing boats, in grinding of grain with windmill, up to the actual production of electricity through the wind energy converters. So, this is how the wind energy is converted into electrical energy. The wind's mechanical energy is converted into electrical energy through the device called the wind turbine. This is the wind turbine. It has the following components. This is the tower. It is a supporting structure of a wind turbine and has the function of observing the vibration generated by the rotary motion of the blade. Second, this is the rotor. It is a rotating part of the wind turbine. It has hub holds the blades while connected to the gearbox via the speed shaft. These are the blades, which is usually 20 meters or more in length depending on the power and level, and 120 degrees from each other, are aerodynamically optimized to capture the maximum power from the wind and to transfer to the rotor hub. The blade is also tilted in order to be always aligned with the airflow. The blade starts to turn when the wind reaches the cut in the wind speed, the point at which the turbine starts generating electricity from turning and stop, and then reaches the cut out speed. The housing holding the gearbox, the braking system, pitch control system, and the generator is called the nacelle, which can move according to the direction of the wind. The wind vane is a velocity sensor that constantly detects the wind direction. The anemometer placed also at the rear of the nacelle that measures the speed and direction of wind, sends a signal to a pitch control system that provides to rotate the entire nacelle and the rotor and the blade to meet the best angle. The pitch control system inside the gearbox turns the blades into their longitude axis to change the angle of attack according to wind's direction. It also blocks the rotation of the rotor when the wind is too strong or too weak. The power of wind in the blade slowly rotates the rotor, but it is not enough to produce electricity. For this reason, high-speed shaft is connected between the rotor and the generator. It is used to reach higher level of rotational speed needed by the electrical generator to produce the electrical power. The rotational energy of the drive shaft turbine is transformed into electrical energy by the generator. The generator is a device that uses electromagnetic induction to produce electrical voltage. The generated electricity is transferred into the device usually placed at the base of the wind tower, called transformer. The transformer acts as a link between the wind turbine and the distribution grid. It steps up the low output voltage from the generator to higher voltage level. This is the generation. The second process is called electric transmission, which is the vital link between power production and power usage. We have here the transmission line and the substation. The transformer can raise the voltage produced by a wind turbine generator from, for example, 2,200 volts into 220,000 volts. The high voltage electricity is then transmitted through the transmission line to substations. Substation is a set of equipment reducing the high voltage of electrical power transmission to the suitable for a supply to consumers. The final stage is the distribution of electricity to consumers. At the substation, a step-down to transformer reduces the voltage to its original value and transferred to the local distribution lines. This is the distribution electrical post and this is the transformer. And the step-down transformer further reduces the electricity according to the standard volts like 220 volts used by consumers. The electricity is distributed to residential, commercial, and industrial consumers through the meter post. This meter post records the usage of electricity of every consumers. So now we know the generation, the transmission, and the distribution of energy. That's all. Bye!